Hello, welcome back to the live class session of Industrial Pharmacy. And in today's class, we are going to discuss about laminar airflow environment and what are the personal requirements that need to be practiced, and the training should be given, how the training is to be given to the personnel of sterile preparations area. All these things we'll be discussing in this sterile products 2 class. So here, the first and foremost thing is laminar airflow environment. So the laminar flow environment is a place wherein you will be using this laminar hood for carrying out any transformation or adding any solutions under aseptic conditions. So in the laminar airflow, we use HEPA filters, wherein you will have two types of laminar airflows are generally being used. One is horizontal type and the other one is vertical type. So now we'll see the phenomenon of how the laminar airflow is going to work. If we consider this figure, this is the laminar flow hood chamber. So here, this is the blower wherein the air will be produced and the blowing of air will be done. And here, this is the, can you see the lines over here, the gray colored portion? This is called the HEPA filter. HEPA filter is placed over here. So the blowing air passes through this chamber and enters into the laminar hood behind the laminar hood area and through the HEPA filter and into the laminar hood chamber. So here in this area, you will be using the products either for microbial transformation or for aseptic transformations. So here the personnel will be here and the containers are placed over here, and the blowing of air will be entering and passing through the HEPA filter, and you'll get the filtered air. And this filtered air is something like class 100 or class 1000 or class 10,000, depends upon the requirement of the class required for the particular action to be carried out. So this is how the laminar flow takes place. Generally, laminar flow is a versatile airflow hood area which is required for generally for transformation of any uh, sterile preparations samples or for inoculations or whatever it may be, okay, for testing procedures or something like that. So laminar flow, horizontal laminar flow is mostly used rather than vertical type. And if you see here, this is how the laminar flow hood will look like, and these are the control panels, and this is the HEPA filter. The white color screen is the HEPA filter, and onto the top you have the lamp. It can be a fluorescent tube or UV tube, and this is the place where the samples are being placed and the process is carried out. So this is laminar flow hood container, and this is the explanation what I've given in the earlier slide. So once again, if you see here, the air enters through the blower, and here you have the HEPA filter, it passes, and the airflow of filtered air will be entering into the laminar flow chamber. So this is the explanation. Whatever I explained, it will be found over here in these slides. So that is why I'm skipping. Now we'll see here laminar airflow hood for vertical type. Okay. If you see in this case, the air entering from the blower will be entering into the laminar flow from the top and through the HEPA filter, and it is the sterile air, the filtered air will be coming from top to bottom. So it will be entering from the top and it will be moved on to the table and it will be exiting out. So that means what? In the vertical laminar flow hood, the sterile air will be coming from the top to the surface of the laminar flow. Whereas in the horizontal laminar flow hood, the air will be blown horizontally to the surface of the laminar flow cabinet. So this is the basic difference between these two laminar flow hoods. Now let us see what is the type of flow that is generally required, or how the type of flow or different types of flow that exist in sterile preparation cell. For example, in this case, the different airflow regimes that are observed on an open neck of a bottle in a horizontal airflow is being seen over here. For laminar flow means when the flow of air is at a minimum level or at a smooth level, or if the Reynolds number is less than 2000, then we'll say as laminar flow. So thereby what happens is the air will be parallel to the surface, and the air velocity will be very much normal, and it will be very smooth, and it will be just having a smooth passage over the container. Suppose if it is turbulent, if you see the third figure over here, turbulent flow means what? When the air velocity is very high, turbulent phenomenon. So the Reynolds number value is more than 4000. In that case, what happens is turbulence is produced. When air is entering, it strikes over here, it creates some disturbance inside the container. See, and it also creates some disturbance on the outside. So this is how the turbulent flow phenomenon will look like on an open bottle neck. See, unstable flow means what? It is neither laminar or turbulent. It's unstable means what? It is not stable. So thereby what happens? It has a different phenomenon. Either it is not smooth nor turbulent. It is normal. You can say. You can say or you can say it is critical or transitional flow. You can say transitional flow means the flow is going right going to transform from laminar flow to turbulent flow. So this is the phenomenon how it's look like. Okay, when you wanted to place the items in a laminar flow area, it should be properly placed at the center of the table. For example, if you say here, this is the HEPA filter, and this is the place where you will be working, and thereby what happens, the air enters through the HEPA filter and it travels in horizontally parallel to the surface of the laminar flow hood. So here the two circles, white circles, are the places where the products are placed, and you can able to remove the test sample from the filled um, container, or you can able to put some lal test. For if you want to do lal test, then you can able to put in some inoculation over here, and you can do at these areas. So if you work in the center of the table, so it will be very much free from turbulence, and you can have a very comfortable transformation of samples can be done. So you should place the products at the center of the table rather than to the peripheries of the laminar fluid hood area. And you should never place that means one behind the other. This leads to cross contamination. So that is how the things takes place. Let us see the aseptic processing, how it happens. When you are going for the formulation development and you have come up with a formula, then what happens is the drug which is used in the sterile preparations has to pass through sterilization process. Then the drug will be added to the product. Similarly, the containers which are used for holding the drug along with excipients are, again, that means the containers are subjected to sterilization process, and those containers are used for filling up of sterile products. Similarly, the closures, that means the caps, the rubber closures or aluminum closures, they are also subjected to sterilization process, and they are used for production purpose. The excipients which are used in the solubility of the drug and for maintaining pH on the various excipients used in the formula, they are also subjected to sterilization process, and they are used for filling up of parenters. Ultimately, what is happening? The drug product, the container, closure, and excipients, which are entirely used in the development of a finished product first they are subjected, each one of them are subjected to sterilization process, then only they are used for that particular process, and they are moved into aseptic processing area, and a final product is being manufactured in sterile filling area. This is how the aseptic processing is being done pictorial. This is the graphical representation. So these are some of the precautions what you have to, if you go through the slides, you'll have a very clear understanding about the precautions that need to be followed in laminar airflow areas. And all the personnel. So what are the precautions for aseptic processing? See here, thermolabile liquid injections, which are sterilized by filtration through bacteria-proof filters, that are to be considered. That means what? Aseptic processing is generally required for preparation of sterile pharmaceutical products, where terminal sterilization is not undertaken. Terminal sterilization means what? Gamma irradiation. So when the products are not subjected to gamma irradiation, so sterilization process is required. So when sterilization process is required for certain injections, sterilization is done by filtration. When you're doing sterilization by filtration, it can able to remove bacteria from the product by using membrane filters. So generally they use 0.22 micrometers membrane filters for removing bacteria when you are subjecting the sterilization by filtration method. Similarly, all the documentation and validation program should be carried out for all the personnel as well as to the equipment in order to have aseptic processing of the equipment. And only trained personnel should be allowed to work in the aseptic area, because all the personnel cannot be suitable for manufacturing of sterile preparations. In sterile preparations, only trained personnel will have stringency in training. They will be given stringent rules, and those people who can able to work comfortably by adopting the trained sessions properly in real time production areas, they are considered for filling up of parental products. So whenever contamination is detected, the source should be identified and dealt with accordingly. So all these precautions are to be considered for aseptic processing areas. Only minimum number of personnel required for aseptic processing should be allowed into the area. For example, like solid dosage forms, liquid dosage forms, and semi-solid dosage forms. The sterile preparations area or the sterile dosage forms manufacturing areas are highly restricted and stringent procedures are followed. That is why minimum number of personnel are employed in sterile preparations area. Only minimum number of personnel are allowed. And the minimum number of people, if they are working in sterile preparations, less contamination will result. That is the main required reason behind for keeping minimum number of personnel. And you have to check for the airflow, aseptic area. All the areas should be thoroughly checked and cross-checked before the process of production is carried out. And all the personnel also should be trained for manufacturing procedures, hygiene procedures, how to maintain regarding the cleanliness, how to supervise the staff, procedures that are need to be practiced during the production areas. Everything is being trained to the personnel. For example, if you see here, this is the sterile gowning area. The face cap is under the hood. If you see here, face mask is there. Then head cover is there. Then goggles are there. Safety glasses are there. Then you have hand gloves, coveralls. Then shoe covers are there. Then boots are there. So everything is being covered, and the product, the person. This is the pictorial representation of a personnel who is working in a sterile preparations area. This is the actual scenario in the sterile preparations area. And this is the graphical representation. So here generally four types of grades are being carried out. Grade A and B is generally used for headgear and for fully covered. That means what? No shedding of fibers and retain particles shed by operators. So in grade A and grade B, highly sterile zones. They are highly sterile zones. So there will be what? No shedding of fibers. No particles are shed by operators. So it's sterile. That means in grade A and B. In grade C, single piece or two piece suits are generally being used and no fibers to be shed. And grade D means protective clothing and shoes are allowed. So thereby what happens is in grade A and B, you have primary garments, secondary garments, and full attire of safety attire, sterile garments are to be worn in grade A and grade B conditions. And here the personnel must be periodically checked for health, and you have to see whether the garments what they are wearing is free from shedding of particles, and you have to see no outdoor clothing is being allowed. Changing procedures, washing procedures should be monitored whether the personnel they are following the changing procedures or not, and the washing procedure are being followed or not. So everything is being monitored and documented and regulated. And no watches, jewelry, and cosmetics are allowed into the sterile preparations area. Similarly, the hygiene of a personnel is very much important. So you have to train and mold the personnel to be hygienic in nature, to maintain hygiene conditions before entering into the sterile preparations area. And if you see, you have to check for contamination. You have to check for the microbial contamination, particulate contamination, and you have to see that everyone are being monitored at every stage. Generally, contamination can be from microorganisms, so it is termed as viable type, and from particles, fibers, it is termed as non-viable currents. So thereby, whatever you have to check for all these, and you have to check for the human personnel who is working in the sterile preparations area for any contaminations, and you have to monitor very carefully, and you have to see that everything goes very well in producing a high quality sterile product. So this completes the session of sterile products on the various requirements for personnel hygiene, laminar flow hood cabins, and cabinets which are used in sterile preparations area. We'll see you soon in the next class. Thank you and have a good day.